Hello, so we're going to start today's webinar. First of all, thank you for attending this webinar. My name is Alejandra and I work on the sales team at Everest Solar Systems, where I assist customers creating projects layouts on our different design tools, answering technical questions, and assist customers with any other inquiry that they may have. And today we're going to talk about how we can reduce roof penetrations on pitch residential roof applications. So if you have any questions, please write them down in the GoToWebinar interface, and we will go through them at the end of this webinar. So to start off, we're going to cover a wide range of topics for today's webinar. I will start with a brief introduction of Everest Solar Systems, continue with the current methods to reduce penetrations on residential roofs, and conclude with an overview of our shear rail system. Everest Solar Systems is located in Southern California, and our parent company's headquarters is located in Germany. We also have a presence in Europe, including Italy, France, the UK, as well as we have recently opened an office in Mexico. We have worldwide presence with over 4 gigawatts installed in over 110 countries. And this is our distribution map. As you can see, we have distributors spread all over the USA. To begin, we will discuss current methods for reducing penetrations for dual rail systems. A common strategy is to use a stronger rail for longer spans. While this is possible to do in many cases, it has some disadvantages. For example, stronger rails are typically more expensive than their lighter rail counterparts, while one would get savings from reduced attachments that is typically associated with spending more for the rail. Another method for reducing attachments is installing the modules in portrait. Installing modules in portrait orientation is a common practice as it greatly reduces material cost. However, there are instances where installing in landscape is a necessity. So this brings us to our final method for reducing penetrations, and that is using a shear rail system, which I will discuss in the following slides. Now we're going to talk about the difference between dual rail and shear rail. Dual rail is a typical installation that has been around for decades that includes 2 rails under a module, as you can see in the left picture. A shear rail system is shown on the right side where a row of modules is shared between 2 rails. Here, we're going to look into a more detailed explanation of the difference between dual rail and shear rail. The red lines shown in this image represent the rafters on a standard pitch roof, which are separated by 2 foot. The rail at the end represent the 2-foot cantilever. In this example, we're going to look at a simple 18-module system consisting of 3 rows of modules in a portrait orientation. We will use the gray lines to represent the rails. Here, we will begin by showing a standard dual rail configuration. The roof penetrations are the blue circles, which are separated by a 6-foot span in this example. In a dual rail installation, this gives us a total of 24 penetrations on the roof and 6 horizontal rails. Let's now look at a way to reduce attachments and material for this system using our shear rail system. As I mentioned before, shear rail shares 2 rails between a single row of modules. So in this case, we can eliminate 2 horizontal rails. We can then shift the location of the rails to a shear rail configuration to effectively reduce the amount of material required for this system. This brings our attachment count to 16 and our horizontal rail count to 4. Because we have less attachments, there is an added benefit of a saving on installation time. So now we will go into a deep explanation of the shear rail system. We will talk about the system benefits, system components, and a comparison between cross-rail shear rail and dual rail system. So with the cross-rail shared rail system, we have fewer attachments and rail because we're sharing a rail in between two modules, as we can see in the picture. So this causes huge savings on labor, cost, and material. Of course, if we have less penetrations, if we have less attachments, we will have less penetrations on our roof. Also, this system has integrated bonding, and you only need one lug per SUV array. Since it's less material, the installation is faster, and where you will be saving around 30 to 40% less in material. Now we're going to look at the main components of the shared rail system. We have two types of rail that we have designed for different wind and snow loads. Our Crossrail 48X is pre-engineered for low wind speed and snow load. An example would be in California, where you can reach up to 6-foot spans with this rail. And our Crossrail 48 is pre-engineered for medium wind and snow loads. And we do have black and matte finish. And now we have here at the bottom, we have the shared rail mid clamps and end clamps. These clamps are universal and bonding. They also have a spring to be self-stand up, and they have a special add-on on which is the black part at the bottom. This is a native installation, and it is designed for the modules to sit under. Since we're sharing a rail in between two modules, there's sit one on each side. And we also have dark and silver clamps. Now we have the roof attachments. We have the Everflash eComp with the slide kit, which has an EcoFasten water seal technology. And we have our Everflash QComp with the slide kit, which features quick mount PV elevated water seal technology. As you can see in both pictures, we have a slider. That's our slide bracket, which gives us 4 inches of adjustability going north to south. And we also have a structural wear connector for the Crossrail 48X, which allows us having a continuously rail. We have also created aesthetic options for our shared rail system. We have the sleeve, which was created based on customer input. So this part is in sleeve for the rail. As you know, the rail is normally a little bit higher in cost than the mill rail. And we know there are many installers that paint the ends of the rail with black paint, but this method usually lasts a few months. With our sleeve, you are able to hide the mill rail at a lower cost. Another option that we have with the system is that you can cut the rail flush to the array, that way the end of the rail would be hidden. And we have the end caps to hide the end of the rail, as you can see in the picture. And we also have an array skirt that I will explain in the following slide. This is our array skirt, and it helps to create a clean front edge. It hides the wires and it hides the mill finish rail. Also, one great feature is that in order to install the array skirt, you don't need any additional parts. And actually, it is already being pre-spaced for the clamps. So the array skirt is installed at the bottom of your array, and it is installed with our end clamps. So no any additional hardware. The array skirt has already been pre-spaced, and it is stackable for shipping. And it is 40 inches, and it works with the module's own portrait or landscape. So here's a picture with our creative aesthetic options and our shared rail system. So we have the pre-assembled shared rail clamps and the add-on. We have our slide bracket, which I mentioned before, has 4 inches of adjustability going north to south to make easier the installation. We have the array skirt and the end cap. Now about bonding and grounding. As I told you before, the shared rail system, you only need one ground lug per array in comparison to a dual rail system, which every row has to be grounded. In this picture, we can see how the system bonds, and we can identify where every part is located. As you can see, the whip block 10.3 is attached to the corner of the array and use a copper wire to connect to the ground. So now we're going to do a comparison between dual rail and shared rail. First of all, let's identify every component in our roof. We have a roof, which is the gray rectangle. The rafters are the black lines that you can see at the bottom. The rails are the blue lines. The penetrations are the black dots. And we also have the non-structural splice that is shown as a yellow line. And our modules are the white rectangles and portrait. So this example is based in San Diego with a wind speed of 110 miles per hour, zero snow load, wind exposure B, and risk category 2. So now this same example with shared rail. We are also going to identify the components on the roof. And as you can see, just by looking at this picture, we have less material in this array. I will show this on the following slide. So doing the comparison on material, we have on dual rail installation 48 penetrations versus 24 on the shared rail system, which this is a huge saving. It's 50% less penetrations, which equals less time. 6 rails versus 4 rails and 12 splices versus 8 structural splices. We can install the same number of modules on the same orientation with less material and less penetrations on the roof. We have the same example now in landscape with the same components and same location and configuration. Now the shared rail system. And now here is where we can see the huge difference. So we have in the comparison on landscape, we have 90 penetrations versus 36 on the shared rail, which represents 60 fewer penetrations for lower cost. 30 rails versus 15 rails, 20 splices versus 12 structural splices. As I mentioned before, we can install the same number of modules on the same orientation with less material and less penetrations on the roof. With this system, we have a maximum versatility, as you can see in this image, with a very flexible design. We adjust to the customer's roof and install in any orientation they prefer. We can do landscape and portrait in the same array. Here is an actual installation of shared rail on camp shingle roofs. This is an 18 kilowatt installation in Oceanside with 6-foot spans using our lighter rail 48X. And this is an example when we were able to combine 2 rows of portrait and 1 row of landscape. We can also install shared rail on a standing seam roof. As you can see, we install shared rail on a standing seam roof with a third-party attachment. We've had really good feedback from our customers since it's faster to install. We have also created a shared rail installation video, which you will be able to find in YouTube, where we show how clamps are one-handed install. Actually, we challenge one of our engineers to show how easy it is. In this video, you will see how to install our system on camp shingle roofs. In addition, we have a training video on how to use a jig to make spacing up rails in an easier way. So if you would like for us to bid a current project that you're working on or a past project that so you can be able to see the savings that you can have with our system, please email us or give us a call, and also visit our website for further information. Does anyone has any questions? If there's no questions, that would be all from my part. Let us know if you have any project that you want us to work out and give you a bill of materials, and you can compare the cost on regards the systems that you're using, and we'll be happy to do it. Okay, I have a question here. Okay, let me read this question. So one question is, which rails are prepared to use shared rail installation? So while I was mentioning the components, we have the 48X and we have the 48. You can both use them for the shared rail installation. Yeah, so we have those profiles that you can use depending on your area where you're located. And with, as I mentioned, with the 48X, you can reach up to 6-foot spans here in California. But we can take a look at your project and determine what's the best rail. Any more questions? Also, I can provide you my direct line if you have further questions. It's 760-657-4001. So if there are no further questions,